Okay, finishing up with the last few problems from the non-calculator portion. Number 26, the function is continuous on the closed interval, so you know the graph has no breaks. Between 0 and 2, values are given in the table above. The equation y equals 1/2 must have at least two solutions in the interval if k is equal to. So two solutions just means that the graph is going to have to cross through hit y equals 1/2 at two separate locations. So let's sketch this graph out. Some information provided. We know order pair 0, 1. We know order pair 2, 2. And we're trying to figure out where can we sketch the graph so that this curve is going to intersect this line at a guaranteed two locations. So what we can conclude is that this y value at x equals 1 must be less than 1/2, right? Because if this k value is at 1/2 or above 1/2, then we can't guarantee that the graph is going to hit a crossover y equals 1/2 twice. So if you look at your answer choices, 3, 2, 1, 1/2, all these are sitting above 1/2. So we need the k value to be below 1/2, and the only option is going to be 0. That will ensure that we cross 1/2 to get to 0, and then we cross 1/2 again to get to 3. To get to 2. Number 27, what is the average value? So average value, we apply average value theorem. So 1 over b minus a, integral from a to b of f of x dx. We just go ahead and put everything in. A and b is our 0 and 2. Here's our function. Clean this up a little bit, we get 1/2. Rewrite the radical as a rational exponent. And if we take a look at this and we want to find the antiderivative, we can't expand this out. We're going to have to rely on u substitution. So we'll let the u value be the portion inside the parentheses, so u equals x cubed plus 1. We find the derivative, du over dx equals 3x squared. Cross multiply, solve for dx, we get du over 3x squared. So as you go through u substitution, we're going to be replacing this piece and this piece as well. So x cubed plus 1 gets replaced with u to the 1/2, or u and then the parentheses raised to the 1/2. Dx gets replaced with du over 3x squared. X squared cancels out. We can push the 3 out in front along with the 1/2 as 1/6. So we will get ready for our power rule. U to the 1/2 becomes u to the 3/2 over 3/2. We flip that 3/2 up as 2/3. We have our antiderivative. Let's bring it back in terms of x, and then we can use the original bounds. So upper bound gets plugged in first. We get 2 cubed plus 1 to the 3/2, 9 to the 3/2. And then plug in 0. 0 plus 1 is going to be 1. So here, that's where we got to be careful. The 0 here is not going to wipe everything out to be 0. The 0 is going to take this x out, but you still have a 0 plus 1 to the 3/2, so there's still a negative 1/9 there. Okay. So let's see if we can clean this up here. 9 to the 3/2, the same thing as taking the square root of 9, which is 3. 3 cubed is 27. So we get 27 over 9 minus 1 over 9, which is 26 over 9. Okay, 28, last problem from the non-calculator portion. We have function which is tangent of 2x. Find f prime of pi over 6. So if we find the derivative, we can then evaluate the derivative at pi over 6. So tangent of u becomes secant squared root of u times u prime. So that means tangent of 2x will become secant squared root of 2x times 2. Clean this up, push the 2 out in front. We have 2 secant squared root of 2x. Now we're going to plug pi over 6 in. Now to make it so that we don't get thrown off by this notation, let's rewrite this using brackets. So that squared is the same thing as saying the entire secant of 2x is going to be squared. Right? Visually, that's going to be more helpful, and also we will get thrown off when we're evaluating. So we have our derivative. We're going to plug pi over 6 in for x, and we get 2 secant of 2 times pi over 6. 2 times pi over 6 is the same thing as pi over 3. And let's evaluate what secant of pi over 3 is. Well, we know cosine of pi over 3 is 1/2. So secant of pi over 3 must be 2 over 1, the reciprocal. So 2 squared becomes 4. 4 times 2 is 8. So f prime of pi over 6 must be equal to 8.